Hey, this is Chase Staker. This is my video explaining how nucleotide excision repair works, comparing and contrasting it with another type of DNA repair, and talking about an article in which talks about nucleotide excision repair. So basically, nucleotide excision repair, I'm going to compare it to base excision repair. Both are somewhat similar. Except in kind of the process of how it happens, but there's a few small differences. So in base excision repair, it's used to fix small damage to single bases. So this is used to repair things that happen pretty commonly, like oxidative damage, water damage, small alkylations, and different things that affect just one or two bases, one or two nucleotides. So how this happens, there's a protein that will sense the damage. The base will then be cut off with glycosylase. The backbone is then nicked by another protein, and then the new nucleotides will be inserted, and then the ligase will seal the nick in the backbone. So it's kind of a quick open it up, put it in, close it up. And then nucleotide excision repair is a bit more comprehensive. It'll help fix bigger problems and things that might not happen as often, but can be even worse if they do happen. So one example would be UV light damage. Being on the sun too much, it can cause base nucleotides to kind of seal together, and those have to be fixed, and that is done using nucleotide excision repair, where a protein will sense the damage both in bacterial and eukaryotic nucleotide excision repair. There's a protein that will recognize the damage and get another protein to come in and cut both sides. And when I say both sides, two cuts. If the damage was done just on a couple bases right in here, it'll cut not just right next to it, but give it a little space, cut on the sides of it. Then there will be a protein that will take it out, and then DNA polymerase will come in and fill in the gap. And then ligase will seal it up. There's a few different proteins, bacterial and eukaryotic. Eukaryotic, there's a protein XPC that can sense it, as well as RNA polymerase 2. But then in both, there are specific proteins that do each of the other different jobs. So pretty simple. The article that I found talks about how nucleotide excision repair protects against cancer, by Errol C. Friedberg in the Nature Reviews Cancer Journal. And it talks about how nucleotide excision repair helps prevent skin cancer, and in how it is sensed. Nucleotide excision repair goes in and fixes those problems, but and then also on how it works somewhat differently on DNA that is transcriptionally active compared to DNA that is transcriptionally silent. And then also about how it's important that if nucleotide excision repair is defective, or the proteins involved in that do not work, that can also cause cancer. And then if that is genetically passed down, you get the skin cancer prone disease of xeroderma pigmentosum passing down through generations, and they are then more prone to skin cancer because the nucleotide excision repair proteins will not work as well and fix those damages from things like UV light. So yes, that is how nucleotide excision repair works.